In this video, we will learn about how to create a cone of base diameter 35 mm and height is 45 mm. And it is resting on one of its circumferential point and the angle of inclination is 45 degree with the HP and parallel to VP. So to create the cone for the given condition, first create a circle and then create a new plane at a height of 45 mm and create the axis point. Then use the loft command between the circle and the axis point so that you can able to create a cone. Then try to rotate it based on the axis of rotation created on the first sketch. Let's do it in Autodesk Fusion 360. Click on Create Sketch. Select the top plane. Here we are going to create the circle for the given diameter. So select the circle command and click on the origin and move your mouse and give the diametral value as 35 and press enter. Now here we need the axis of rotation. So for creating the axis of rotation, draw a vertical line. Change the line as a construction line. Right click over the line and change it as normal bar construction. Apply tangent constraint between the line and the circle. So select the tangent constraint and click on the circle so that the line and the circle will be in tangential constraint. Click on Finish Sketch. Now we need to create the cone by creating the apex point at the given height. So here the given height is 45 mm. Let's try to create a plane at an distance of 45 mm. To create a new plane, go to Construct, click on the drop down menu, select Offset Plane. Here the offset plane which we are going to select is a top plane because on the top plane only we have created the circle. So select the top plane and click and drag, or you can directly give the value of height here. So the height of the cone is 45. So you can type here or just move by dragging the arrow mark. So here I am giving the value as 45 and select OK. Now select the new plane which you have created and click on Create Sketch. So here I am going to create the apex point for the cone. The apex point is exactly just over the center point of the circle. To create the exact concentric point, go to Create, select Project Bar Include and select Project. Here select the center point or origin point here and select OK and give Finish Sketch. Now you can get your apex point here. To create the cone, use the Loft command. You can find the Loft command under the Create Group tab. So click on Create, select the Loft, and here we need to select the profiles in order. So click on the plus icon under the profiles and select the circle area first, then the apex point next. So it will automatically create the cone. Once the cone is created, click on OK to confirm it. Now we need to rotate the cone based on the reference axis we had drawn on the first sketch. But here, once the 3D model is created, defaultly all the sketches will be disabled. To enable the sketch, go to the browser, ungroup that sketches. So you can see all the sketches under the sketches folder. Enable the sketch one. Now you can see the axis. Let's try to rotate the axis based on this reference axis. To rotate the object, click on Move Bar Copy under the Modify group. So here, which body we are going to move? It's the cone. And make sure the move type is rotate. And select the axis as this axis. And let's come to the front view. You can see this is the axis of rotation. And I need to rotate it on the right hand side. And the angle should be 40 from the horizontal plane. So from the vertical, it should be 50 degree. So make sure the angle is 50, but it should be negative because the positive value is rotating on the other side. So make sure the value is 50 and negative value because the positive value you can see here, it is rotating on the other side. I want to rotate it on the right hand side. So let me give the value as minus and give OK. Now we have created the plane for the given condition. If you want to hide the sketch which is visible, go to the browser. Under the sketches folder, you can hide by pressing the eye icon so that you can see only the 3D model, the front view of the cone, and the top view of the cone. That's all for this video. Thanks for watching.